Assalamu alaikum. In this video, I will discuss about some basic concepts of thermodynamics. Thermodynamics is a study of energy and its transformations. To talk about the basic concepts, first comes system. System in thermodynamics means a region in space which is under study or investigation. This is a system, and everything outside the system is called surrounding or environment. So we were just thinking about this system, and a system and its surrounding is separated by a boundary. This is called system boundary. This boundary can be real or imaginary. For example of real boundary, we can think about a gas cylinder. Suppose this is a gas cylinder and this is surrounded by a real boundary. And for imaginary boundary, we can think about a turbine, like particles coming inside, going outside. There is no boundary, but we just think that there exists an imaginary boundary, and the volume surrounded by this imaginary boundary is called controlled volume. This is called controlled volume. Now, types of system. There are three kinds of system. Number one is open system. Number two is closed system. Three, isolated system. In open system, both mass transfer and heat and work transfer both are possible, like mass coming in, going out, coming in, going out, heat coming in, work is done, or heat can go out. Everything is possible. Like mass transfer and energy transfer by heat and work, this is possible. In closed system, no mass transfer, only energy transfer by means of heat and work. This is possible. Like in a piston, here some working fluid is here, so nothing is going outside, no mass is going outside, just some heat can come inside and work is done, or heat can go outside. So only energy transfer is possible in closed system. In isolated system, nothing is possible. No mass transfer, no energy transfer. Everything is confined in an isolated system. No energy transfer. For example of isolated system, we can think about a whole universe is a perfect example of isolated system. All the planets and stars are inside this universe. No energy is coming inside or going outside, nothing. Everything is confined in this system. So this is an isolated system. So to summarize, in open system, both mass and energy transfer possible. In closed system, only energy transfer by means of heat and work. In isolated system, no mass transfer, no energy transfer. Let's talk about property. Property in a system is any characteristics of the system. So any characteristics of a system is called property. Characteristics like pressure, volume, temperature, enthalpy, entropy, density, like this, so on. There are three kinds of properties. First of all, intensive property. Then number two is extensive property. And number three is specific property. intensive properties are the properties which are not dependent on mass. Not dependent on mass. Extensive properties are dependent on size or extent, and specific property are per unit mass of extensive property, or extensive property per unit mass. For example of intensive property, we can think about temperature. This doesn't depend on mass, pressure, density. So temperature, pressure, and density. And extensive properties depends on size or extent. Here we can see the volume and energy. These things depends on size or extent. So these are extensive property: volume, energy. And specific properties, extensive properties per unit mass. So we can say that specific volume is per unit mass of volume per unit mass, that is V by M. And specific energy equals to E by M. Now a very important concept, that is state and process. So at first, state is any point of a system of constant properties. Like in PV diagram, think this is a point and the coordinates of this point is P1, sorry, V1, P1. So this is a state. Another point, this one, this is V2, P2. This is another state. Like in TV diagram, this can be one point. This is V1, T1. So here we can see that at least two property is required to express a state. At least two property required to express a state. And the process, change of state from one state to another state, is called the process. Like we can think this is state 1 and suppose this is state 2. So if any system goes from state 1 to state 2, this is defined as a process. So any change of state is called process. There are different kinds of processes, like number 1, isobaric process, number 2, isochoric process, number 3, isothermal, and later I will add more like adiabatic, isentropic, polytropic, like this. These ones I will discuss later. At first, let's talk about isobaric process. In isobaric process, pressure remains constant. Isochoric process, volume constant. Isothermal process, temperature constant. So in PV diagram, we can show isobaric process. This process starts from state 1. In isobaric process, we will follow a constant pressure line, state 1 to state 2, and isochoric process, this will follow a constant volume line. And this is state 2, this is isochoric process. And isothermal process, this will be like, the diagram will be like this. This is isothermal process, and more other processes will come eventually. I will discuss it in other video. Reversibility and irreversibility of a process. If a process can return to its initial state without causing any change to its surrounding, this is called reversible process. Like if a process goes from state 1 to state 2 following this curve, and while falling back it follows the same curve. While going it followed this line, while coming it followed this line, so the net work is zero. So in reversible process we can say that the net work and heat exchange between the surrounding is zero, so there is no change in between in the surrounding, so the process is a reversible process. An irreversible process is the net it causes change to its surrounding, like while returning back to its state it cannot follow this line, like it comes back to its initial state but it follows a different line. There is a difference of work and heat exchange, so the environment or surrounding is changed, so this one is irreversible process. In reality all the processes are irreversible process. The causes are temperature gradient, temperature gradient, pressure gradient, pressure gradient, and most importantly friction. For all these reasons all the processes are irreversible process. But if we want to think in different way, we can divide the reversibility in two ways. Like number one is internally reversible, internally reversible. Number two is externally reversible. In internally reversible process, we are just thinking about the system boundary. This is system. So thus inside this system there is no irreversibility. We are not at all bothered about our surrounding. In the inside the system, it comes back to its original state. So this type of system here is called, this type of process is internally reversible process. And in externally reversible process we are not bothered about our system, we are, the environment or the surrounding comes back to its original position or original state, there is no change of the surrounding. This type of processes are externally reversible process. Topic is equilibrium. Equilibrium is a state of balance, that means there is no unbalanced potential within a system. That means a system doesn't change its state spontaneously or without any external help, it doesn't change its state, that is equilibrium. Equilibrium can be different types like mechanical equilibrium, chemical equilibrium, thermal equilibrium, phase equilibrium. In mechanical equilibrium there is no pressure change. In chemical equilibrium there is no reaction. In thermal equilibrium there is no change of temperature. In phase equilibrium there is no change of phase. So this was all about our today's video. Thank you for watching.